Hello everybody, welcome to chapter 1.2 part 1b. Here we are going to do more converting of bases. What we did in the last part was to convert back and forth between base 5 and our base 10 system and back again from base 10 to base 5. Of course, we can do this with any other bases such as 6, 7, 8, 9, or whatever. Notice how the numbers get smaller as the bases get larger and vice versa. So, for example, looking at example 6, we're going to convert 4, 1, 4, base 7 into base 10. So let us go to the whiteboard and see how we do this. And again, I'm going to first show you how it would look in blocks for those who like to see a visual representation, and then work it out on the table. In this example, we have 4, 1, 4, base 7. And I've tried to put it in terms of blocks. So we're going to pretend that this is a base 7 flat, this is base 7 flat, this is base 7 flat, and this is base 7 flat, and there are 4 of them. And then we have 1, which means we have a base 7 rod, and then we have 4 units. So what we're going to do is we're going to try to make a base 10. How many base 10 flats can we make from what we have here? Well, we can put these two together, and that will make 98, 99, 100. So that's 1 base 10 flat. And then similarly, we can do here, 98, 99, 100. So now we have 2 base 10 flats. And we don't have any 10s because this is not a base 10 rod. What this really is 7 units in the base 10 world. 1, 2, 3, 4, 5, 6, 7. Because a rod in base 7 really only consists of 7 units, which is not enough to make a rod in base 10, which would consist of 10 units. So that rod we have to break into 7 units. So that says this would be equivalent to 1 base 10 flat. This would be equivalent to 2 base 10 flats. And this will be equivalent to 7 units. So that would mean that 4, 1, 4 base 7 is equivalent to 2, 0, 7 in our base or in base 10. Now let's look at how we would look at this particular example using a table. So I'm going to go back to the whiteboard and work it out using a table. Here we're going to convert 4, 1, 4 base 7 into its equivalent in base 10. So we want to figure out our table as we did with the other bases. And so on the bottom line here, I'll put 4, 1, 4. And here, this is 7 to the 0 power column. This is 7 to the first power column. And this is 7 to the second power column. Well, 7 to the 0 is our 1s. 7 to the 1 is our 7s. And 7 squared is 49. So that's our 49s. So now we'll multiply 4 times 49 and add 1, be consistent, 1 times 7 plus 4 times 1, and that will give us 196 plus 7 plus 4, and when we add all of these together, we get 207, and that's our base 10 equivalent, which we usually write as 207. So 4147 is equal to 207 base 10. So they mean the same thing, but their bases are different. So remember, in the case of when it's different than base 10, it's very important that you put that little 7 there so that we know that it's in base 7. With the base 10, and that's what we converted it to, we don't have to, because that's our usual base that we deal with every day. Now let us summarize what we just did on the whiteboard. So here we now make a table using base 7 and place 414 base 7 in the proper columns as follows. So here I have 7 squared, 7 to the first power, 7 to the 0 power, and then we solve 7 squared, 7 to the first power, 7 0, and we see we multiply 4 times 49 equals 196, 1 times 7 gives us 7, and then 4 times 1 gives us 4. And then we add them all up, and we get 207 base 10, but I don't usually have to write a little base 10 here because it's in our number system. In example number 7, we're asked to convert the number 207 into base 7. So again, let's go look at the blocks and then the whiteboard and work it out both in blocks and the table to see how we can do this. I set this example up as to show that here are the base 10 blocks of 207. So we have 2, 100, 200 for the 2, and then 1, 2, 3, 4, 5, 6, 7 units. So what we can do is we can break each of these 100 units into 2 49 units, or 7 squared. So this would be 7 squared, this would be 7 squared, and then a leftover unit. And we can do the same thing here. This would be 7 squared, this would be 7 squared, and leftover units. So each of these represent 49, 49, 49, and 49, and we got from here, and there are the units. Now we have 7 units here, and 7 units would make one base 7 rod. So that means in the end, in base 7, we have 1, 2, 3, 4 flats. So that would be 4. And then we have 1 rod, so 4, 1. And then 1, 2, 3, 4 units. So this would be 4, 1, 4 base 7. Let's look at this example using a table. Here in number 7, we're going to convert 207 in our base system to something base 7. So in order to do this, we're going to construct a base 7 table. So we're going to have 7 to the 0, 7 to the 1, which is 7. Then we have 7 squared, 7 cubed, etc. Now it turns out, because 7, 0 is 1, 7 to the 1 is 7, 7 squared is 49. And if we go higher to 7 to the cubed, it's going to be too high and it'll go over 207. So we're not going to need this. So we're only going to need up to here. So what we're going to do is we're going to look at 207 and divide that by 49. We're going to see how many times 49 goes into 207 as a whole number without going over it. So we find out that that is 4. But 4 times 49 gives us 196. So that means there's going to be a remainder here. So we take 207 minus 196, and we get 11. So here we'll have 4 with a remainder of 11. Now for the next, the 7's place, we do the same thing. We'll take 11, our remainder, divided by 7. And we see that 7 can only go into 11 once as a whole number. And because 11 minus 7 will give us 4, that means the remainder is 4. So here we'll have 1 with a remainder of 4. And then finally, we have 4, and 4 divided by 1 is equal to 4. So this is just 4 without any remainder. So now we have as our answer 414 base 7 is the same thing as 207 in our system, which is base 10. Reviewing what we just did on the whiteboard, as you probably have noticed, we're now going the other way from example 6. So we're going from 207 base 10 into base 7 and see if we get back what we had in number 6. So we use the base 7 table and ask how many 49s go into 207. And we find that there are 4 with a remainder of 11. And then we take the 11 and then we divide that by 7, and we see that we get 1 remainder 4. And now lastly the 4 goes into the 1's place. So we construct the table as follows, and we get 4, 1, 4, base 7. And again, remember, you always must write the little base here when it's anything other than our base system. In example number 8, we're asked to convert 273 base 12 into base 10. Now in this example, I'm not going to show how it would be done in blocks, because after a certain point, blocks become impractical. So the only way to really do this properly is to do this using a table. So I will show you how to look at this example using a table on the whiteboard. Here we're going to take 2 3 base 12 and convert it into our base 10. So we'll make a base 12 table. And how will we do this? Well, the same way we've done all the other bases. So in this case, since we're going from the other base, not our base, we'll just write in 3, 7, 2. And then we have here for 12, 12 to the 0 power, 12 to the 1 power, and 12 to the second power. And anything to the 0 power, and that will be our 1s. Anything to the first power is itself, so that will be our 12s column. And then 12 squared is 144, and that's our 144 column. So now we multiply 2, 144, plus 7 times 12, plus 3 times 1. And that's equal to 288 plus 84 plus 3. And we add them all together and we get 375. So that means that 273 base 12 is the same as 375 base 10. In reviewing what we just did on the whiteboard, we make a place value table for base 12, like we did for base 5 and base 7. And here is our place value table. So we have 12 squared is the 144's column, 12 to the first power is the 12's column, 12 to the 0 is the 1's power, because as mentioned, anything to the 0 power is 1. Then we multiply the digits by each place value and add. So here we have 2 times 144. Here we have 7 times 12. And here we have 3 times 1. And 2 times 144 gives us 288. 7 times 12 gives us 84. And 3 times 1 gives us 3. And then we add all of those up. And that's how we would get 375. In example number 9, we're asked to convert 394 into base 12. So again, let's go over to the whiteboard and work this out in detail on the whiteboard using the table, since doing it using blocks is not very practical. Here we have 394, and we're going to convert that into our base 12 system. So we're going to set up our table, and we see we only have to go as far as 12 squared, since after that it's too high and goes beyond 494. So I'll make the table. So we have 12 to the 0, 12 to the 1, and 12 squared. And 12 to the 0 is our 1s, 12 to the 1s is our 12s, and this is our 144s. Now, as we did with the other bases, when we're converting from our base system to another one, we're going to do division. So we're going to find how many whole 144s are in 394. And it turns out that there are 2. And then we're going to subtract 394. And from 2 times 144, so that will give us 394 minus 288. And that means we get a remainder of 106. So we can write here now 2 with a remainder of 106. Now we want to see how many 12s are in 106 without going over it. So we want to see how many whole 12s are in 106. So it turns out that there are 8. So 8 times 12 is equal to 96. So now we take 106 and subtract 96 in order to find our remainder. And we find that it's a remainder of 10. So we can now write here 8 and remainder 10. Now we go over here and we have 10 so we have 10 over 1. So we'll write that in there. But there becomes an issue because we can't write 2, 8, 10. This will not make any sense. Base 12. This will make no sense. So this is garbage. So what we do is we call T 10 and we call E 11 to deal with that issue, where T stands for 10 and E stands for 11. So now we substitute in where we see 10, and now we write in, it's 2, 8, T. Base 12 is equal to 394 base 10, which is our base system. Because of course this is larger, and that is too large, and that would not make any sense. So here is how we would write something where we have a 10, and if that was 11, instead of a T, we would write an E. But it's 10, so we write a T. Let's review what we just did on the whiteboard when we converted 394 into base 12. So as usual, we make a place value table for the powers of the different bases. In this case, it's base 12. So here's our table, and we have the 12 squared, which is the 144 column, the 12 to the first power, which is the 12's place, and 12 to the 0. And as I mentioned, anything to the 0 power is always the 1's. Then we divide 394 divided by 144, and we get 2 remainder 106. And then we have take the 106 divided by 12, and we get 8 remainder 10, and then we get 10 over 1 is equal to 10. But the issue that comes up here is with the 10 left over. And we cannot have 2,810 base 12. This does not make sense. So what we do instead is in base 12, we use a T to stand for the tens, and if it's 11, we would use E. So we write 394 is equal to 28T, and I put the little base 12 right here, and this would be how you would write your answer. The reason why we use T for 10 and E for 11 is that in base 12, we are allowed to have up to number 11 in any place value column. In our system, base 10, we can only have up to 9 in a place value. This means we cannot write 2810 base 12 because that would seem like we are trying to write something over 1000. So instead, in base 12, we use T to stand for 10 and an E to stand for 11. So we write 394 is equal to 28T base 12 for our answer. Thank you very much. I hope you liked this video and that it helped you understand different bases a little bit better. And take care. Be well. Bye.